All right, let's look at inverse trig functions. This notation, y equals sine of negative 1x, means the inverse. So it means that we switch the x and the y. Recall that inverse, you're going to switch the x and the y. So now we've changed our domain and range. So in a sine graph, remember that our domain is all reals, and our range is from negative 1 to 1. All right, let's graph this function. Let's graph the sine function. So it's 0, high, 0, low, 0. And reverse the pattern. All right, so that's the sine graph. Now notice here that if we take the inverse of this, if we use the horizontal line test, the inverse of a sine graph will not be a function because a horizontal line touches our graph in more than one spot. So here we want to make a restriction. We want the inverse to be a function. So that means we need to restrict our range in order for the in order for the inverse of this to be a function. So we're going to restrict our domain between negative pi over 2 and positive pi over 2. So that way, when we take the inverse, it will also be a function. So our restriction is going to be from negative pi over 2 to positive pi over 2. And if you read at the beginning, in order to obtain a unique theta for each a trig function has an inverse, you must restrict the domain. Domain restrictions allow the inverse functions to be defined. Now, another way of representing the inverse sign is also called the arc sign. The arc sign of x is just another notation that means the inverse of sine. You're going to switch your x and your y. So y equals the arc sign of x. And we'll show you how that comes to play in a minute. All right, let's look at the same thing with the cosine function. Here again, let's graph our cosine function. All right, so this is our pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. All right, so this is 1. So this high, 0, low, 0, high, and reverse it. All right, so here is our cosine function. All right, again, notice that if I draw a horizontal line, the inverse of this is not going to be a function. So here again, we're going to restrict it. We're going to restrict our domain so that when we take the inverse, it will also be a function. All right, so where are we going to restrict this? If I do it between negative pi over 2 and pi over 2, the horizontal line is still going to touch it twice. So that's not going to be a restriction. So let's go to the closest thing around 0. What if we start at 0 and end at pi? So we're going to restrict it to just this part of the graph, because then our inverse will also be a function. So that restriction on here is from 0 to pi. And the whole goal of this is to keep so the inverse will also be a function. Here again, we can write the inverse cosine of x as y equals the arc cosine of x. All right, finally, let's look at tangent. All right, with tangent, remember we have asymptotes at pi over 2 and 3 pi over 2, and negative pi over 2 and negative 3 pi over 2. I'll let this be 1. All right, every one of my scale is pi over 2 here. All right, so let's draw our tangent function. All right. Now here again, notice once again, if I draw my horizontal line, it's going to touch my graph in more than one spot. So the inverse of tangent is not going to be a function without some restrictions. So let's decide where are our restrictions. We want to keep the inverse also a function. All right, so hopefully you noticed here, if we restrict this thing between negative pi over 2 and pi over 2, then we'll have a function. But the negative pi over 2 and pi over 2 are asymptotes, so that means this is open. So we're from negative pi over 2 and positive pi over 2. Where it was closed in sine, it's now open in tangent because there's asymptotes at pi over 2. All right, other notation, the inverse tangent can also be written as y equals the arc tangent of x. And you should be, like I said, be able to understand either one of them, that kind of notation. All right, how is this? How are we going to use this? Why are we doing this? All right, here's the types of problems you're going to be responsible for. Evaluate the expression in both radians and degrees. So this is inverse. So our answer is going to be an angle. This question is asking, is the inverse cosine of -1, wants to know what theta, what angle, has a cosine of -1. That's our question. All right, so let's think backwards. First of all, because it's cosine, we're restricted to 0 to pi. So our answer is only going to be something in those quadrants, the first and second quadrant. All right, where is cosine -1? Well, here we have the point 0, -1, which corresponds to pi. Let's back that up. Let's rewind for a minute. Let's undo that and start over. I got my right answer, wrong coordinate. Okay, so let's go backwards. We're restricted from 0 to pi. All right, so where do we have an x value of -1? So -1, 0 corresponds to pi. So the inverse cosine of -1 is equal to pi. All right, let's try the second one. All right, tangent. We're restricted from from negative pi over 2 to pi. All right, what angle has a tangent of square root of 3 over 3? Should be the 30-degree family. Now, since this is positive, we want the 30-degree family. We're in the first quadrant and the fourth quadrant. Tangent's only positive in the first quadrant. So that means our answer is pi over 6, which is the 30-degree family. All right, so they want it in radians and they want it in degrees. So that means we should have had this answer as 180 degrees also, because that's what the directions are asking us for. All right, inverse sine of 0. All right, think again here again. What are the restrictions on sine? It's between negative pi over 2 and positive pi over 2. All right, where is our y coordinate 0? So at 1, 0, so the sine of 0 equals 0. So my angle here is 0 degrees, which is also 0 radians. All right, sine again. So my restrictions are between negative pi over 2 and positive pi over 2. Since we want our result to be negative, we know sine is negative in the fourth quadrant. So that means we're going to have an angle down in the fourth quadrant. All right, so what family is this? Hopefully said the 45 family. But since we want to be in the fourth quadrant and I'm restricted between negative pi over 2 and positive pi over 2, my answer is going to be negative pi over 4. So negative pi over 4, which is equal to negative 45 degrees. All right, tangent. Here again, we're restricted between negative pi over 2 and positive pi over 2. All right, so we need to figure out where, okay, what angle has a tangent of 1? And we want a positive 1, so that means we're going to be in the first quadrant. All right, an angle with a tangent of positive 1 is going to be 45. So my answer is 45. Pi over 4 radians or 45 degrees. All right, how about cosine? Cosine restricted to from 0 to pi. All right, now, what angle has a cosine of 2? Well, you're probably scratching your head right now. Cosine of 2? Well, it's not possible. Remember, cosine can only be between -1 and 1. So we can't have an angle with a cosine of 2. So that means this is not possible. All right, let's look at solving equations now. All right, so we're going to solve this equation. What angle has a cosine value of square root of 2 over 2? Now notice our restrictions. So we're told that we have to be between 270 and 360. So we're only in this quadrant. All right, well, cosine, we want a theta that has a cosine. So theta is equal to the inverse cosine of square root of 2 over 2. Well, that's the 45 family. All right, what is the 45 family member in the fourth quadrant? Well, let's count 45s. You got 1, 2, 3, 4, 5, 6, 7. So this is 7 pi over 4, which is 315 degrees. Since our problem started out in degrees, we want to continue in degrees. So that means theta is equal to 315 degrees. All right, find the measure of the angle theta in this triangle shown. All right, so we're looking for this angle measurement. Here's where you're going to have to use a calculator. So this is opposite hypotenuse. So this is sine. This should be a familiar problem that you did in geometry. So this is going to be the sine of theta is equal to 5 over 13. All right, so theta is going to be the inverse sine of 5 over 13. Put this in your calculator. Make sure your calculator's in degree. And we should get about 22.6 degrees, which we're not going to write as radians. Degrees are fine. But this would have to be a calculator question. All right, solve the following. So we want to know what angle has a sine of negative square root of 2 over 2. And notice that we're on the entire circle here. So where is sine negative? Well, sine is negative in the third quadrant and the fourth quadrant. All right, what family member is this? 45. So we want to know what is the 45 degree measure in the third quadrant and in the fourth quadrant. All right, so 1, 2, 3, 4, 5. This is 5 pi over 4, and this is 7 pi over 4. Since this is in radians, we want our answer in radians. So we're going to have two answers. X is equal to 5 pi over 4 and 7 pi over 4. All right, we've got to do some math here first, do some algebra first. Let's isolate the sine of x. So we got 2 sine of x equals 1. Divide by 2, so sine of x is equal to 1/2. All right, notice our restrictions. We only want to be from between 0 and pi. So in these two quadrants, where is sine positive? Well, sine's positive in both the first quadrant and the second quadrant. So we're going to have two answers here. All right, what family has sine of 1/2? All right, hopefully you said the 30 degree family, so pi over 6. All right, so in the first quadrant, we got pi over 6. Not a good place to draw. Yeah, that's good. Pi over 6. All right, in the second quadrant, what do we got? We got 1, 2, 3, 4, 5. So 5 pi over 6 is our second answer. So x is equal to pi over 6 and 5 pi over 6. All right, we're going to have to factor this one. So think about this. Think about it as like 2x squared plus x minus 1. So what multiplies to give you negative 2, but adds to give you 1? So what's that? We're on a positive, so it's going to be 2 and negative 1. All right, so this is going to factor to 2x and x. I want a positive 2 and a negative 1. All right, in place of the x, we're going to put our signs back in. So this is 2 sine x minus 1 and sine x plus 1. All right, let's get rid of this. All right, so zero product property. I'm going to set 2 sine x minus 1 equal to 0. And I'm going to set sine x plus 1 equal to 0. All right, solve for sine. So I got sine x is equal to 1/2, and sine x is equal to negative 1. All right, notice I'm working on the whole circle here, the entire circle, from 0 to 2 pi. All right, let's figure out. All right, sine's positive. Sine's positive in the first quadrant and the second quadrant. So let's work on a sine of 1/2. All right, 1/2. What family is that? Well, we just got finished doing it. This is the 30 family, so pi over 6. So that means one of our answers is pi over 6. And then in the second quadrant, we're at 5 pi over 6. So our two answers are pi over 6 and 5 pi over 6. All right, second part of the equation. Sine x equals negative 1. Where is sine negative 1? Well, it's going to be down here, right? 0, negative 1. Our y value is negative 1. That corresponds to the angle 3 pi over 2. So our third answer here is 3 pi over 2. So we have three answers: pi over 6, 5 pi over 6, and 3 pi over 2. Everything that makes those conditions true. All right, so now we're going to move to a different type of question. Notice the wording on this question says, write the general solution. That means it's going to have an n in it. We want it to go around the circle as many times as we can. We're not putting a restriction on it. So that means all of these answers are going to have an n involved in it. That's the number of rotations around the circle. That's what n is going to represent. All right, let's solve for tangent. So I got the tangent squared x is equal to 3. Square root both sides, so tan x is equal to plus or minus the square root of 3. All right, so let's look at, we're looking at the whole circle first. So we got plus or minus. So we got to take it everywhere that tangent is positive. So let's look at these two first. All right, what family has a tangent of square root of 3? It should be your 60 family. All right, so we're going to, so if we're positive here at pi over 3, and we're also positive here at 4 pi over 3. All right, let's look at those first. We want to write a general solution. So if I made n number of rotations around my circle, I would get to another answer. So let's start out. Look, how far are these two angles apart? What is that distance? Well, you notice it's a straight line, so that means it's pi. So that means I'm going to add a multiple of pi to this. So I'm starting at pi. So my first answer is pi over 3 plus n times pi. That'll get me to, so if I added 1 pi, n is 1, I'd get to 4 pi over 3. If I did 2, I'd be back up here, okay, with adding pi to this. So it's 7 pi over 3. And every time I add pi, I would end up back on another answer. So that's what the n pi does. Gives us all possible answers. All right, now let's look at the negative ones. So I'm going to get rid of this without getting rid of my whole deal here. Actually, let's just draw it over. Okay, let's go back. So now I need the negative ones. All right, so tangent is negative in the second quadrant and the fourth quadrant. All right, I've got my pi over 3. All right, what is... So in the second quadrant, my 60-degree angle is going to be 2 pi over 3. And then in the fourth quadrant, it's going to be 5 pi over 3. Notice here again, these are pi apart. So that means I'm going to add a multiple of n pi. A multiple of pi, which is n, represented as n pi. All right, start with the smaller angle, which is 2 pi over 3, and we're going to add n pi. These are what we call general solutions. They're going to have an n involved in it, plus n something. And that depends. It's not going to always be n pi. It depends on the problem. And we're going to look at them all the same way. All right, find the general solution. All right, we got a factor here. Let's factor out a sine of x. So we're left with sine squared x minus 4. All right, this is difference of squares, so factor again. So I got sine x plus 2, sine x minus 2. Use a zero product property. So sine x is equal to 0, sine x is equal to negative 2, and sine x is equal to positive 2. All right, hope you got some warning signs going off here. Remember, sine can only be between negative 1 and 1, so these two are not possible. Not possible. There's no way we can get an angle that has a sine of 2. So that means we only have to deal with the sine of x. Okay, so let's think about it. What do we got? Where is sine 0? So where are the y coordinates 0? So we're here, we have 1, 0, and over, so at 0, and then over here at pi, we have negative 1, 0. So sine is 0 at both 0 degrees and pi. All right, I want a general solution. So how far away are these two angles? Pi. So that means we're going to add a multiple of pi. So n pi is going to be added to our answer. Take the lower angle, which is 0, and add n pi. So simplify that. So my answer is n pi. Okay. All right, so we'll have to factor. So what multiplies to give you 4 and adds to give you negative 4? That would be negative 2 and negative 2. All right, so how's this thing going to factor? It's going to be 2 cosine x. And I want them negative, so it'll be negative 1, negative 1. So it's a perfect square trinomial. Well, it's the same thing twice. I really only need to set one of them to 0. All right, solve for cosine. All right, let's see, what are we doing? We want a positive 1/2. So cosine is positive in the first quadrant and in the fourth quadrant. All right, what family has a cosine of 1/2? So that's the 60 family. So pi over 3. All right, so we're at pi over 3 here. All right, and we're going to be at pi over 3 down here. So at 5 pi over 3. All right, now notice that these don't make a straight line. We're not pi apart anymore. So this is going to be a different multiple. So let's look at, so to get around, so we're going to have two separate answers here. So what is our multiple going to be? How do we get back around? If we start here, what do we have to add to get back to another positive angle in the first quadrant? We're going to have to go all the way around and add 2 pi. So that means our multiple is going to be pi over 3 plus 2 pi times n. So this is typically written as pi over 3 plus 2n pi. That's the way you're going to see it. But we're multiplying by multiples of 2 pi this time. Alright, same thing with our 5 pi over 3. So how we're going to get back around to that angle? If we start, we're going to have to go all the way around again. So here again, we're going to be a multiple of 2 pi. So it's going to be 5 pi over 3 plus 2n pi. Both of these are my answers. Okay, so with the cosine, you're going to have to do a multiple of 2n pi for your general solution. Okay, a couple more problems. All right, let's solve for tangent. So I'm going to square root both sides, so I get the tangent of x is equal to plus or minus 1. Okay, let's look at all of these because this is kind of a special situation. All right, what family member has a tangent of 1? And since I want the positive and negative, I want to be all the way around my circle. All right, 45 families have tangents. So I've got 45 pi over 4. I've got 3 pi over 4. 5 pi over 4. And 7 pi over 4. Alright, because we're going all the way around our circle, we can just have one equation to represent all 4 of these angles. So think again, how far are they apart? Well, 45 plus 45 is 90. So that's pi over 2. So every multiple of pi over 2, we're going to get to another answer. All the way around and keep on going forever. So that means my general solution is going to be x is equal to pi over 4, the smallest angle, plus multiples of pi over 2. So n pi over 2. All right, last question. Different type of question. If they tell me the arc tangent is 5 over 12, then I can set up, this is going to represent an angle, so I can set up the following triangle. And because it's tangent, I know that 5 is opposite and 12 is adjacent. Now, it's asking me for cosine. Cosine is defined as adjacent over hypotenuse. So that means I need to find my hypotenuse. All right, so hopefully you remember your Pythagorean triple. So the hypotenuse is 13. So now they ask us cosine. What's the cosine of this angle? Well, cosine is adjacent over hypotenuse. So the cosine of theta is equal to 12 over 13. So that's our answer, 12 over 13.